Phone cases, plastic water bottles, Legos, and even your car's dashboard. What do they all have in common? All of these items were produced through a technique known as polymer injection. Polymer injection is the most widely used manufacturing process to mass produce these plastic parts. This is due to the fact that injection molding is incredibly efficient, as it is able to mass produce these items without air. The polymer we are injecting in this lab is known as cycolac. You can commonly find cycolac used to create car parts, luggage, and even bumpers. It has a variety of properties which include its heat resistance and toughness, making it the polymer of choice for these products.
Amy is dressed horrendously for labs, so she will be showing how she avoids getting a demerit. But for some reason, she remembered to wear closed-toed shoes today, so that's her one victory for the day. First, she puts on long, loose pants in case of chemical spills, and then she puts on a lab coat for the same reason. Next, she puts on safety goggles to protect her eyes. Lastly, she puts her hair up to avoid it getting caught in lab equipment. She is now ready to tackle lab. Now that we're all dressed, we can go into lab safely. No demerits here. Now that we're inside the lab, we must wear insulated gloves when removing dried polymer from the oven. Careful, it's hot. The oven was heated to 95 degrees Celsius. And for all my fellow Americans out there, that's 203 degrees Fahrenheit. That's very hot. Now let's discuss injection molder safety. First, we need to find the emergency shutdown button before turning on the molder, and we have to be aware of moving parts. Injection molding can reach temperatures greater than 175 degrees Celsius or 347 degrees Fahrenheit. Molten plastic can burn skin, so don't put your hands in the molder without gloves. Only polymer can go into the hopper, so keep hands, long hair, and loose clothing away from it. And don't put fumes produced by the molten and burned polymers into your lungs either. Lastly, be careful when closing the clamps on the tensile testing machine. It can hurt your hands.
The first step in this process was to load the necessary amount of cyclolac into the hopper. The amount of cyclolac should not exceed the halfway mark. Each dog bone requires about 10 grams of polymer, and we calculated these amounts before transferring it into the machine. We also made sure that there were no leftover pellets from the previous runs using a vacuum. Next, we set up the inlet temperature to be about 180 degrees Celsius, and this is meant to basically just soften the polymer as it moves through the molder. The machine was set to semi-automatic settings where the cycle was controlled by just pressing one button. Every other part of the process outside of pushing the button was automatic. One safety concern that we needed to make sure we did: whenever a sample was stuck, we got help from Ethan and Professor Genthoff. The procedure was repeated about 30 times to ensure all of the previous pellets were completely clear from the machine. We ran the experiments multiple times under varying conditions to make sure the samples were enough for tensile testing. And at the end of our experiment, we cleared the pellets using a vacuum once more. Tensile testing was done on a machine known as Instron, which is hooked up to a computer. The machine is operated using the computer as a monitor for this process. The first step we took before attaching the dog bone to the machine was measuring the length, width, and thickness of the polymer sample. Next, this data was inputted into the computer, which generates the Young modulus curve. After this, we attach the sample to both ends of the stretcher, which applies a pulling force across the material until it broke.
Our goal for this lab is to test how varying injector cooling time affects the tensile properties of cycolac. The result of this experiment can tell us about how much force was applied to a polymer per unit area before the polymer split in half. This is known as the engineering stress. We can also learn how much of the material stretched prior to breaking, which is known as the engineering strain. Both of these properties are vital to manufacturers using injection molding, as it can help them perform quality control measures on the products before they reach the consumer's hands. Cleanup is rather easy for this lab. First, we take the cycolac that has been dispensed from the injection machine, and we place it into the polymer waste bin located next to the machine. We then take a vacuum and vacuum out the remaining cycolac pellets from the hopper. This way we can ensure that the machine is empty of any remaining polymer for future trials. From there, we sweep up the floor and tidy up the area before leaving the lab.